Hey everybody, this is Larry. This is day 2 of the Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's poem. The contest is in about an hour. We have a easy poem, so seems like we'll be okay. My foot is a bit better today. I am able to earlier walk at that 20-minute per mile cutoff pace, but I mean, I only did it for a mile today. I want to rest, So we'll see how that goes for tomorrow, especially since I'm trying to also walk, that is, more naturally, because it's just kind of tough to walk naturally because I haven't been doing it for like a couple of weeks. So yeah, very silly things, honestly. But yeah, anyway, today we have a easy problem, so let's take advantage of it, and then we'll, set up for the contest in a little bit. Let's see. Give me a second. Alright, I have 1752. Check if array is sorted and rotated. Alright. Given an array nums, return true if the array was originally sorted in non-decreasing order and rotated some amount per position. There may be duplicates in the array. Okay. I mean, yeah, the thing I want to... okay. I mean, obviously, there's an n squared solution, right? N squared being that you just rotate it and then you rotate up to n times and just check, and that'll be n squared, right? Can I do better? I think the key idea would be to find a period, right? Or I call it period, maybe that's not the right terminology actually, but just like the first instance in which I guess you don't even need to do. I was thinking of like maybe doing some binary search, but actually you don't even have to, right? Because you can just assume that if this is the case, then you're fine, right? And you could do a linear search, that's fine, so you don't even have to assume anything. So maybe that's actually not true. Yeah, and then once you get the smallest number in the array, you can start there and then go from left to right. The only tricky thing is that there may be duplicates, right? So if they're duplicates, if it's sorted, it will have to be next to each other, so it'll have to be leftmost. But we can figure that out. That's not so bad, I think, right? Yeah, I think we just find the first instance in which that is true, and if all the numbers are the only case where that is not, that doesn't have an instance, is if all the numbers are the same, right? So if all the numbers are the same, then we're done anyway. But otherwise, yeah. Yeah, I think that's it, right? Okay, so we have to find the smallest number in an array. But keeping in mind that it's not the first instant of the smallest number, but it's the smallest number that's after the biggest number, if you will. So yeah, I mean, what I mean by that is that you have like 1, 2, 3, 4, ... 1, 1, 1, 1, 1. Well, you want this one and not this one, right? So okay, so I think that's basically the idea. So how do I want to phrase that? I mean, of course, like I said, this is an easy problem. If this was a contest, I would do an n squared solution real quick and just like, solve the rest of the problems. But let's see. But for now, maybe it's worth for me to slow down because I feel like I go really fast, but incorrectly with a lot of silly mistakes, which is not the same as just being right. All right. So basically, if num sub I is, I mean, it doesn't even have to be the smallest number per se. I mean, you can do that for sure, but you can actually just do something like that, right? If the first instant in which the previous number is equal to, or is bigger than that, right? So right, then first is equal to I. Yeah, I think that should be good. And actually, in a funky way, we can rotate this to the end. I know in Python, -1 actually goes to the last element, but I don't like to rely on that. Just because it's sometimes you could wrap around twice. I mean, obviously not for -1, but there are other cases, and then you just kind of silly, right? Okay, so if first is none, then first is equal to 0, maybe. I don't know. That means that yeah, you sort of And then now that's basically where you rotate, right? So then now for I in range of n, or maybe I want to say offset, right? So if num sub I plus offset is less than or equal to num sub I plus offset plus 1, then we're good. So that means that the opposite is true. So that if this is bigger, then we return false. And I think we actually do this n-1 time because we don't want to do the last element. And I think that's it, maybe. But it's very easy to get wrong. So honestly, if I have to rate my confidence level, right now it'll probably be like, I don't know, 60-40 or something. Well, especially if I forget to mod n. So even less. But I mean, I meant the algorithm. Like the coding, like clearly, it's very easy to make mistakes. But the idea about this algorithm, maybe it's okay. I don't know. I mean, the thing is that there are no duplicate numbers in any of these examples, which is the case that is more interesting, at least for me, what I care about. Right, something like that maybe. And there are also some, of course, cases where, you know, maybe you have a 1 or something like that, right? This gives me more confidence, but let's, you know, let's see. Oh, that's good. Okay, good. Yeah, 1769-day streak. Yeah, this is linear time, constant space. We don't really do any spacey things, and that's it, right? Huh. Okay, yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.